Hello grade 9, how are you? Hope you all are safe. Today we will learn about using reactivity series, how to extract metals from their ores using the reactivity series. Let's talk about the reactivity series and what we have learned about it. We said previously about the reactivity series is a list of metals in order of how vigorous their reactions are, and we said the most reactive metals are in group 1 and group 2 elements. These are the metals which are the most reactive ones, and we said also that the metals in the bottom of the list are unreactive metals, and also about the reactions. The most reactive metals can corrode easily, which is joining with the oxygen easily. Reaction with the oxygen is too easy. What about the reaction of the displacement reactions of these metals? These metals in the group 1 and 2 can replace other elements or more than other elements. And we said also about most reactive metals can displace less reactive metals from solutions of their salts and from their oxides also. Now please take out your notebooks and write down these notes. These are the main points of the lesson, okay? And this is the next page of the lesson about a pattern of reactions, aluminium, and how can we extract aluminium by electrolysis. Now please, if you are done, open your books, page 194, 195, and let's start our lesson. This lesson is talking about how can we use reactivity series to extract metals from their ores. Please grab your highlighter and highlight these points. Metal compounds and reactivity series. The higher a metal in the reactivity series, the more strongly its atoms are joined to atoms of other elements in compounds. We talked about this in replacement reactions, and we said aluminium can displace iron more easily, and aluminium oxide atoms are joined together, which is aluminium atoms joined to oxygen atoms more than iron itself, more than the iron oxide. So this is the meaning of the higher metals in the reactivity series, because aluminium comes above the iron in the reactivity series. And the more strongly the atoms of a compound are joined, the more difficult it is to extract an element from the compound. Extracting gold. Gold is unreactive. It's found as an element in the Earth's crust. The metal is easily separated from the substances it is mixed with. Here we have a question, okay? Why gold is unreactive? We studied before about reactivity series, and we said gold comes at the bottom of the reactivity list. So that's why it's unreactive. And we can find it as an element not joined to other elements in the Earth's crust, and we can find it in the stream beds, okay, mixed with sand and gravel. We can separate gold by placing the mixture in a pan and adding water. This process itself called panning for gold. So this process is when you place this mixture in a pan and then you add water, the gold will sink down and the gravel and sand will float, and you can separate gold from it. So gold is more dense than sand and gravel. It sinks to the bottom of the pan. All this process we said called panning. Extracting metals in the middle of the reactivity series. Let's talk about iron. Iron, we can find it in the middle of the reactivity series. Most metals are not found as elements in the Earth's crust, and iron is an example of these elements. Okay, because the iron can be joined to other elements in compounds. The compound must be broken down to get metals out of it. Iron is a vital metal. Why it's a vital metal? Iron, we are using iron mainly in everything, or most of these manufacturers, we are using iron to make tables, to build ships, in building houses. They are using iron. So iron is very important in our life. But the problem is that iron can be found as a compound, and can exist as oxides. We should extract this iron from the oxide, so we can get iron alone and we can use it. So, how can we extract this iron from the oxides? The oxides are heated with carbon. Carbon is more reactive than iron. It removes oxygen from iron oxide. So, we have here another question. Oxides are heated with carbon. Explain why. Here is the answer. Carbon is more reactive than iron, so it removes oxygen from iron oxide. So that's why we are using carbon. And also, carbon is easy to find, and also it's cheap. So that's why we are using it to extract the iron from the oxides. Now, let's go to the next page. Lead. People have used lead for up to 8,000 years. Lead beads were made in Turkey in about 6,500 BCE. Skilled craftspeople made lead objects in the Indus Valley about 4,000 years ago. So lead is wide used, and they discovered lead thousands of years, and they were using it more than 8,000 years ago, and they made a lot of craft with it. And you have as this picture on your right about this statuette. This lead statuette was made in Greece over 3,000 years ago. So this made of lead. Lead also is a vital metal, so that's why they are using it like very old days. Lead exists as lead sulfide in the earth crusts. So we talked about iron, and we said iron is exists as iron oxide. But here lead exists as lead sulfide in Earth's crust. Lead is extracted like this. We have two steps to extract lead. First, we need to heat lead sulfide in air. That means we need to join oxygen atoms with lead sulfide, and this will give us lead sulfide plus sulfur dioxide, and we can get lead oxide. So we didn't extract lead yet, so we need to have another way to extract lead. Now we convert lead sulfide to lead oxide, and now we should heat the lead oxide with carbon, because carbon can replace the lead, and we can extract lead alone. Carbon is more reactive than lead, and why it's more reactive? It comes above the lead in the reactivity series, so it can remove oxygen from lead dioxide. So lead oxide plus carbon give us lead plus carbon dioxide. Now let's see the pattern of the reactions. Zinc and metals below zinc in the reactivity series can be extracted from their oxides by heating with carbon. The reaction works because carbon is more reactive than these metals. Okay, let's look at the reactivity list here that we have. Look at the carbon position here. Carbon position here, and below carbon we have zinc, iron, tin, lead, hydrogen, copper, silver, gold, and platinum. So carbon comes above zinc, so zinc and all these metals above zinc can be heated using a carbon. Of course, I mean the oxides like iron oxide, zinc oxide, tin oxide, lead oxide, and all these compounds. Carbon is chosen because it's cheap and there is plenty of it. We can find it easily, we can buy it easily, it's not expensive. It's possible to extract iron from iron oxide by heating with more reactive metals like magnesium. We can use also magnesium to replace and extract the iron from the iron oxide, but the problem is that magnesium is rarer than iron. We cannot find it easily, and it's much more expensive. So that's why we cannot use magnesium. Okay, now this was about extracting the metals in the middle of the reactivity series. Now let's go to the extracting metals at the top of the reactivity series. We said that the metals at the top of the reactivity series, their atoms are joined to other atoms in the compound very strongly, and it's very hard to extract them. So how can we do this? Let's look at the aluminum. Aluminum is one of the examples. Okay, aluminum is can react vigorously with oxygen and produce aluminum oxide. Aluminum oxide is very hard to extract, so how can we get the aluminum from aluminum oxide? Aluminum is near the top of the reactivity series in the Earth's crust. It exists as aluminum oxide, so we don't find aluminum alone as an element, but we can find it as oxide. The aluminum and oxygen atoms are strongly joined together. So carbon doesn't work. Here, carbon doesn't work to extract. We cannot use carbon because carbon, as we said earlier, comes below. So it least reactive, so we cannot use it. So carbon is not reactive enough to remove oxygen from aluminum oxide. So we have another way, we have another process. This process called electrolysis. Electrolysis is a process using current, strong current, weak current. We use electricity. That's why we call it electrolysis, okay? So aluminum is extracted from its oxide by electrolysis in two steps. First, we need to dissolve pure aluminum oxide in a special solvent to make a solution, and then we need to pass 100,000 amp electric current through the solution. Here, the electricity splits up aluminum oxide. Liquid aluminum is produced. I summarized these points for you, and I need you to write them in your notebooks. It will be easy for you to study. So we said first we need to dissolve pure aluminium to make a solution in a special solvent. Then we need to pass 100,000 amps current through this solution. The electricity here will work to split up the aluminum oxide, and then we can get liquid aluminum from this compound. Other reactive metals are also extracted from their compounds by electrolysis. That's why I told you we use electrolysis, because it's powerful and it can split these reactive metals from their compounds. Sodium is extracted by passing an electric current through seawater. So that's how can we extract sodium from sodium chloride, which is the seawater. Now I'm going to show you a video about extracting the aluminium oxide, extracting aluminium from aluminium oxide.
In electrolysis, ions need to pass through the electrolyte, and so the aluminium oxide must be made molten so that this can happen. Aluminium oxide has a very high melting point, over 2000 degrees Celsius. So instead of trying to melt it, the aluminium oxide is dissolved in molten cryolite. Cryolite is an aluminium compound with a much lower melting point than aluminium oxide, and so using this reduces some of the costs in extracting aluminium. The steel case is coated with graphite, providing the negative cathode. The positive anodes are immersed in the molten cryolite and are also made of graphite. Remember that graphite is a form of carbon. When the battery is turned on and electricity flows, the aluminium from the aluminium oxide in the cryolite forms at the negative cathode and sinks to the bottom of the tank. Here, it can then be tapped off as a pure liquid metal. The aluminium sinks because it is more dense than the aluminium cryolite solution. The oxygen from the aluminium oxide in the cryolite forms at the positive anodes. The oxygen reacts with the carbon of the graphite, forming carbon dioxide. The positive anode therefore burns away and needs replacing regularly. This is another reason for the extraction of the aluminium being so expensive. The overall reaction is aluminium oxide to aluminium plus oxygen.
Okay, now this video was talking about how can we extract aluminium using electrolysis. So let's take a quick review about the summary of what we studied in this lesson. We were talking about the reactivity series and how can we use the reactivity series to extract metals from their ores. So, metal compounds and the reactivity series. The higher a metal in the reactivity series, the more strongly its atoms join to atoms of other elements in compounds. How can we extract gold? By panning, because gold is unreactive, so we can find it as an element, and found as an element in stream beds, and easy to extract. Extracting metals in the middle of the reactivity series, these metals like iron and lead, we can find them as compounds. Iron can exist as oxides, but lead can exist as sulfide. So iron, we can extract iron by heating with carbon, because carbon is more reactive than iron, so it will displace the iron with oxygen and form carbon dioxide. Also, lead can be extracted by heating, but not directly, because we have to do this in two steps. First, we need to heat lead sulfide in the air, so atoms of oxygen will join to the lead and form lead oxide. In this way, we can extract it by heating with carbon. So this is step 2, which is heating the lead oxide using a carbon to form carbon dioxide and lead. We saw also a pattern in the reactions, and we said zincs and metals below can be extracted from their oxides by heating with carbon, because carbon is more reactive. It's above the zinc and these other metals in the reactivity series. How can we extract metals at the top of the reactivity series, like aluminium and sodium from sodium chloride, we need to extract these elements using electrolysis. First, we need to dissolve the aluminium in special solvent, and then we need to pass a current, which is very powerful current, 100,000 amps, through the solution. So the electrolysis will split aluminium oxide, and we can get liquid aluminium oxide. So this was all about extracting metals from their ores. I hope you understood this lesson, and if you have any question, please write it down and I will answer it immediately. Stay safe and see you soon. Bye.